Good morning, students. I was hoping that you can join me to my virtual lesson today. But I just want to let you know that the last day to turn in late assignments is June the 12th. Please check your grade and see if there are any assignments that you would like to make them up, and I'll be very happy to open the window for you. In addition, please check your grade because the system was not calculating the test grade accordingly. So I have to reset it yesterday and some of your grades changed. And send me a private email in case that you have any questions or concerns. Today, my objective is to talk about geometric sequences. So now, last class we talked about arithmetic sequences. And arithmetic sequences were when the change was consistent. So when you were adding or subtracting the same number throughout the whole sequence. Today in geometric sequences, we are going to find out that they are exponential. So it's going to be a number to the power of n. What we need to know about these sequences is that I'm going to need the first term on the sequence, which is a, and the common ratio between two consecutive numbers. And the way that we're going to write them out is by putting the a, which is the first term, parentheses, VR, and then the exponent on the outside. Guys, if you look at this formula, it looks a lot or very similar to an exponential behavior on the graph. So if we're graphing a geometric sequence, it can either go up or it can go down. But remember, we don't connect the dots on a sequence. It's just I'm showing you the behavior of a graph of a geometric sequence. So let's apply this formula. In this case, I'm going to write the geometric sequence to the nth power. So I'm going to start by saying that the first number on the sequence is, so I'm just going to write this down. We can figure that out. The first number is 3. The ratio is 2. And you want to make sure that you use parentheses here in case that you have a negative number, which we're going to talk about in a few minutes. Sometimes you're going to try to find the sequence when the R is not given to you. So what I'm going to do first is I have the first term, and I'm going to find the common ratio. So I would take two numbers on this sequence, any two numbers you like, about in a few minutes. Sometimes you're going to try to find the sequence when the R is not given to you. So what I'm going to do first is I have the first term, and I'm going to find the common ratio. So I would take two numbers on this sequence, any two. So I'm going to take these two terms. I'm going to start with the third term divided by the second. And then I'm going to simplify this problem, outsiders, insiders, and simplify this. So the formula for this sequence will look, I don't need to put a 1 on the front because it won't make a difference. Parentheses, 1/3 and minus 1. Move on. Example number 2. Find the ratio first. Find the first term. Find the nth term. So I'm going to write the formula on the top. We can visualize this better. And then I want you to find the eighth term. Okay. So I figure that the A number is 5. To find the common ratio, I take two numbers on the sequence, third over second, and divide. To find the nth term, I'm just going to use the previous formula. So A, parentheses on the ratio, we don't want to make mistakes. And now to find the eighth term, I'm just going to plug in 8 for n. I'm going to use the calculator to find out that this number is going to be 10,935. The geometric sequences are growing exponentially fast. So please don't be afraid that these numbers might be extremely large. So I know that the first number on the sequence is 2. To find the R, I'm going to take two numbers and find the common ratio. And I take a negative with me. Because the ratio is negative, it means that your signs are going to be alternative. Okay? Positive, negative, positive, negative. And now we set this up and I'm done. If and only if the ratio is in between 0 and 1, we say that the sequence is, and if R is more than 1, we say that the sequence is increasing. And that, let's make that a rule. Example number 3. It says that the third number on the sequence, so the third number on the sequence is 63/4. And the sixth number is this crazy fraction. So now they're asking you to find the fifth term. This is what I want to find out. So I don't have the A yet, I don't have an R. I'm gonna use the genetic formula first and use the information given to see if I can figure this out. So I know that this term is the third term on the sequence. I don't know what the A is. I don't know what this number is, but I know that this is the third number on the sequence. And I will do the same for the second one. This is my sixth number on the sequence. I am going to rewrite the same thing in a simplified format. I notice that this is a system of equations because I have two unknown variables. But what I need to find out right now first is the ratio. I am taking this fraction and dividing by this. Outsiders, insiders, simplify the problem a little bit more. Okay? And we're going to simplify this problem. So first I notice that these two cancel. I'm going to divide these variables. And I do the same on the other side. I am solving for R. So I'm going to cube root both sides of this equation. Okay. Once I have the R, my job is to find A. because I need A as well. So what I'm doing is I'm going to take one of the original forms from the top, one of the original components, and plug the information that I have. In this case, I'm going to take the smallest equation and plug it in. So I'm going to take this to find A by using substitution. And I'm going to solve for A. In this case, my A value is going to be 7. Now that I have the information, I'm going to set up the formula for the sequence. And now it's asking you to find the fifth term. So I'm going to place 5 for n. Be careful when you're plugging this into your calculator. And sometimes these numbers are not very friendly, like in this case. Now guys, if you're taking notes right now, it is important that you write this formula very clear with the title Geometric Sequence Partial Sums. All the sequences have different formulas, but if you connect the word geometric with this, then when you are taking the quiz or your test, you can always come back to your notes and match the proper formulas with the problem. What I suggest doing here though is make sure that you use parentheses around this big fraction here, just to avoid any calculation mistakes. So now what I'm going to do is says find the partial sum, keyword geometric. So I know I have to use this formula. According to this formula, I'm going to need the first term on the sequence, the common ratio, and r to the n. So I'm going to first find the r by dividing two consecutive numbers. And now that I have this, what I'm going to do, 3 terms, then I added a bunch of numbers in the middle until I get to this term, which is a to the nth, but I am not sure what term number would that be. So what I'm going to do first is I'm going to set up the genetic formula. And I want to visualize this. So it's basically saying to me that this item is going to be 4 because it has to match the same base, right? Base is 4. So 4 to the what exponent gives you that number? But the formula tells me that you got to use n minus 1. So the a to the 7th number is this. Now that I have that, then I'm going to use the sum formula by plugging the nth to be 7. The a number is 1, and I plug that in. When you are doing this, my recommendation will be to use a calculator and enter the numerator altogether first, and then the denominator. Divide those two numbers together to find out that we're going to have a positive. number. When we are finding the sum of a geometric sequence, we are just going to use the same formula, which I'm going to write it on the side. And we use the sum sigma notation here. So it says, okay, first I'm going to need the first item on this sequence. So to find the first item on the sequence, I'm going to plug in 1 into the problem. To find out that A is 7. I know that the ratio is 2/3. And now I'm going to set up the problem because I am adding the first 6 numbers on this sequence. And I'm going to plug that in. Be careful with the double negatives here. Same on the bottom. We're going to take the calculator. I know that these fractions can be a little hideous. So the sum in this case is an approximate of 3.83. I didn't have to do all the math on the side. If we only look at the formula on the top, I knew what the first number was going to be. And I also knew the ratio given. Those were geometric sequences. But we also have infinite geometric series. So what I need you to think about is a fraction or a decimal. For instance, some decimals that look like this. We know that the pattern here is going to be 31, 31, 31, and it goes on forever. So those are how geometric infinite series look like. And we represent them by using this. On the top, as we can see, is a infinite sign, which I know it refers to a geometric sequence. Okay. When we have a geometric sequence, again, we represent the sigma notation as this with the infinite sign on the top. If R is less than 1, it converges. And to find the sum, we use this formula. If R is bigger or equals than 1, we say that this series diverges. So for our next problem, it says we have an infinite geometric series. We want to know first if it converges or diverges. And then we're going to find the sum if it is possible. So let's do example number 1. I'm going to bring this formula down so we can visualize it. So what I'm going to do first is I'm going to find out what the R is because I need to know whether it converges or diverges. I know that the first item is 2. To find R, I take two consecutive numbers and divide by each other. According to my definition, if R is less than 1, which in this case is this, so I'm going to try to make this as simple as possible. So first, I'm going to write this number down. And we know that number 51, and only 51, only the part 51 is going to be repeating forever. So what I'm going to say is first, 2.3 is not part of this infinite geometric sequence. So I'm going to take the 2.3 on the side and save it for later. Because I'm changing this into a fraction, I think I will change this to a fraction and save this for later. If I'm looking at my decimal, I know that this will be my 10th place. This will be my 100th, and the 1 will be my 1,000. But these two numbers are together. So it's my 1,000th place. So what I do is I'm going to write 51,000 on the bottom because it's 1,000th place. So what that means is that the next thing I'm going to be adding is 51, not to the 1,000 now, but to the 100,000 place, and then continues on forever. I know that the first number on this geometric sequence is 51 over 1,000. I need to find out what the R is, so I take two consecutive numbers and I divide them together. To find out that the R is going to be 1 over 100. But the question is to write this as a fraction. So I'm going to use the sum formula and I'm going to set this up. So the first number on my sequence is 51 over 1,000. 1 minus the R value. I'm going to simplify the bottom part. Simplify this more. But that is not what I need. This only represents the repetitive part. Not the whole decimal. Just the 51, 51, 51 part of this decimal. So I take this item, which is the original 2.3 part of the problem, and I'm going to add the repetitive part of this decimal. These fractions are very large, so my suggestion would be to use a calculator. So this fraction represents 2.3, 51 repeating. I would like to do one more problem just like this. So I'm going to find out a fraction that will be equivalent to the rational number given. So I'm trying to write this as a fraction. So first I'm going to identify the infinite series, which is this. I'm going to take this item separately and write that part as a decimal. As a fraction. And I'm going to be adding some fraction that represents the repetitive part of this. So on the side, I'm going to say this item represents 73 over 1,000, thousandth place. And then it keeps going forever. To find the R, we know that it's going to be 73. And because it's the same as the other problem to the thousand, I know that this is going to be that. So I'm going to take the repetitive part of this problem and add them together using a calculator. So this fraction is equivalent to the rational number above. Okay guys, so your assignment for today is to take the short quiz in Canvas. Send me some questions before 2:20 if you want, and I'll be happy to assist you. And then continue with your web assignment 12.3. We are going to have a quiz on 12.3 next class. And we are going to start chapter 13, limits. Next week, I would like to meet with you every class that we have for that week. And I hope everything is okay with you guys. Talk to you soon. Goodbye.